Welcome to the walkthrough for Assignment 1B. The objective of the second part of this two-part assignment is to deepen your experience using Android Studio to develop and test an implementation of an array interface written using a combination of Java's object-oriented and functional programming features. It's important that your array implementation work properly, since variants of it are required by all subsequent assignments in this course. The code you write for this assignment has a GUI and runs as an app. Please use this GUI to help debug your solution. The following resources may be helpful in completing this assignment: the Java Utils Arrays documentation, as well as the Oracle Java tutorial itself. Before you start with Assignment 1B, you'll need to complete your implementation of Assignment 1A and incorporate any necessary changes into your Assignment 1B solution based on my review of your Assignment 1A submission. The Image Crawler app is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purpose of Assignment B, however, you only need to be aware of the following three directories: the Image Crawler Utils directory, which contains the skeletons you'll need to fill in based on the previous Assignment 1A, the App Source Test directory, which contains many Java unit tests that exercise the features under test, and you should use this to evaluate whether you've correctly satisfied the assignment requirements, and finally, the assignment test instrumentation test that runs your app automatically. To compile this code, you'll need to use the provided Android Studio project. As always, you can run this project by clicking the green Run App button on the Android Studio IDE, which should automatically select an Android emulator to run, assuming you've created one already, which you should have for Assignment 1A. The application's minimum API is 29, so you'll need to select an emulator that uses an API that's at least 29, although I recommend you use API 30. And of course, if you haven't already created the Android Studio's AVD Manager emulator, make sure you use that and create it. An array is an abstract data type implemented via a single contiguous buffer that provides operations like get, set, add, remove, and size. Your task is to implement a generic array class in Java. This class is different from Java's built-in arrays in various ways. For example, you can resize it, and you can also use it in conjunction with other Java collection framework classes. Your task in Assignment 1B is to implement the generic array class in Java that includes methods like replace all and for each that use Java 8's features, such as functional interfaces like consumer. You'll need to modify several files containing Java skeletal code by completing the to-do you fill in here tasks to provide a working solution. As always, please don't change the overall structure of the skeleton. Just fill in the to-do tasks, but please don't remove the to-do tags because I use those to help do my reviews quickly. In particular, you're going to need to modify the contents of unsynchronized array.java. Now, note that this is a new version that's different from what you did in Assignment 1A, so you'll need to copy the individual method implementations into the unsynchronized array.java file. Don't just replace the file, otherwise you'll blow away all the new stuff that's in there. And of course, you should implement the to-do statements that correspond to what you're doing. So, for example, the graduates will implement the 1B versions of the assignment, and the undergrads should implement the appropriate ones for them. They'll be specifically marked in there so you can tell what to do. There's also another slight change. There's a new file called student.kt, which is a Kotlin file. And you'll need to complete the to-do tag there, which is very simple. Just set the field to include whether you're compiling for graduate or undergrad credit, depending on the version of the assignment that you're implementing. Obviously, the undergrads set the undergrad field and the grads set the graduate field. And that way the tests know how to run properly based on what type of course you're taking this as. Moreover, graduate students or students who are taking this course for graduate credit have to do some additional work. You'll need to implement the splitterator interface. Likewise, undergrads now have to implement the iterator interface, which is what grad students had to do in Assignment 1A. And you can see some videos here for more information on Java splitterators. We'll also, of course, be covering splitterators in the class too. Try to avoid using loops as much as possible. You should be using arrays.copyof or system.arrayCopy wherever possible. There's a handful of places, I think it's really just one or two places where you'll need to use regular loops, and that's okay, but try to avoid them whenever they can be replaced with copyof or array copy, because those are typically less error prone and also usually more efficient. The skeleton code for this assignment is available in my GitHub account. Once you've set up your GitLab account, which you already should have done, you can pull the skeleton code into your repository, read it, and then complete the to-do markers. And of course, grad students should do the additional work. Make sure that you're thoughtful about how you integrate the code. There's some examples in the course wiki that explain how to merge code from my repository into your repository, and make sure you take a close look at that or post questions to Piazza if you run into any problems. There's also a very extensive battery of unit tests that are provided to increase our confidence and, of course, your confidence that your implementation is working as it's supposed to. And you'll need to learn how to run the tests. I will show you shortly in this video how to do that. It's pretty straightforward. As always, testing is imperfect. It only demonstrates that bugs exist, but not that bugs don't exist. So make sure that you rely on other features like reading the code carefully and thinking about your solution in order to detect and resolve any problems that occur in your code. As with assignment 1A, this assignment is intentionally designed to be easy to help you get familiar with using and installing Java and Android Studio, and also, of course, with using Git and GitLab and GitHub. And you'll also get a chance to learn some of the core Java Ada object-oriented and functional programming features. I think everybody did pretty well in assignment 1A, so hopefully this won't be too hard. If you are still struggling with it for some reason, please contact me right away, and we'll talk about various ways to get you some help. Now that we've walked through the specification, let's go ahead and take a look at the skeletons you'll have to fill in. We'll start first with the student.kt file. This is slightly different from what you had before. What you'll need to do is open up this file. It's in the utils folder along with unsynchronized array.java, and you'll need to go ahead and set this type to indicate what you're taking the class as. Are you taking it as a graduate? Are you taking the class as an undergraduate? Please just go ahead and set one of these things. Don't set both of them. And that will go ahead and get things set so that the appropriate tests will be run. So with that out of the way, let's now go ahead and take a look at unsynchronized array. A lot of this class is the same as before, but please don't just copy the file over blindly because I've made some changes to add some new things. And if you do that, you'll blow away all the changes. So go ahead and make the changes to my comments, to address my comments for assignment 1A, and then copy in each of the method bodies into the implementations here. So, of course, you'll fill in all the places you did before. Make sure you address my comments, of course, but these are pretty much what you did before, so I'm not going to go through all that stuff again. What I will do is show you the parts that have changed a little bit. And one thing that you'll be doing here is that the undergraduates and the grads are both implementing the iterator this time. And so you can see here that if you're a graduate, you should have implemented the iterator as part of assignment 1A. If you're an undergraduate, now you'll implement it as part of assignment 1B. In this particular case, you'll simply go ahead and write the code to make the array iterator. That's very straightforward, of course. Then there's also a couple other new methods. These were not in the file before, and we'll talk about a bit about them. So one of the methods is called replace all. And what you'll do here is you will go ahead and use a for loop. And this is one of the very few places where you'll need to use a for loop. And when you look at the solution and puzzle over it for a while, you'll see why you need to use a for loop. So you use a for loop here to essentially go through every element in the underlying array, and you'll replace each element with the invocation on the unary operator parameter. So there's a parameter called operator. And so what you're doing is you're going through and you're replacing all the elements with what the operator is producing. So you'll have to sort of puzzle out how you're going to do that. And like I said, you'll need to use a for loop here. Then down here, you're going to see the for each method. This is a little bit more interesting than the replace all method. And that's because you're going to have to go back and re-implement some of the behavior for assignment 1A and for assignment 1B. We hadn't quite got around to integrating this method in with assignment 1A, but now we're going to have you do it. And it'll be pretty straightforward to do it, but you need to think about this. So for the graduate students, if you're taking the class for grad credit, in the assignment 1A part, you need to implement for each using a for each loop. And then also as a graduate student, you'll be implementing assignment 1B, where you're going to have to implement it using the stream for each method. And we'll be talking about the stream for each method. It's fairly straightforward, but you'll have to do that. So those are the two things you'll do as graduate students implementing for each. And basically what for each does is it will go through every element in the underlying array and essentially accepting the element into the consumer action parameter. So you may recall we talked about consumers when we discussed functional interfaces, and this is an example of how you implement something like that. The undergrads have two implementations here as well. One was should have been in assignment 1A, but we'll fix it now. And then the other one is for assignment 1B. In the one for assignment 1A, you can fill it in using a simple index-based for loop, where it's for I equals 0, I less than m size, etc. And you'll do it that way. And then you'll also implement it for assignment 1B using a for each loop. So the implementation for assignment 1B for undergrads will look like the implementation for assignment 1A for grad students using a for each loop. And then the grad students in assignment 1B will go on and use the for each method from Java Streams. And that way we're keeping the grad students sort of one step ahead, but everybody will eventually get a chance to implement all the different features. So that's what you need to do for each. So make sure you think about how to do those loops, and grad students think about how to use the for each method. And as always, please don't hesitate to ask questions if you run into problems. Then down here, you can see that the grad students in assignment 1B and then the undergrads in assignment 2A, which we'll get to in subsequent weeks, need to basically implement this splitterator factory method. And so grad students, for now, because that's what we're focusing on, will implement splitterator, and that will be used to do splitteration, and then we'll look at the splitterator down below. So here's the array iterator. Now both grad students from assignment 1A and now undergrads from assignment 1B will be implementing the array iterator class, and you'll have to fill in the various fields here that I designate and then fill in the implementations of the has next, next, and remove methods. So that's what you'll be doing at this point. Now the grad students will also have to come over here and implement the array splitterator. And again, if you take a look at the specification, there's links to some videos that talk about splitterators. And splitterators are basically steroids, or they're basically iterators on steroids. They go above and beyond what the classic iterator does, and they have some really cool features, only a few of which we will address in this particular context. So you'll have to implement the try advance method and the try split method. And those are fairly straightforward, and they're really cool. And when we get to talking more about streams, and particularly parallel streams, you'll see why the splitterator is such a powerful and useful capability that's part of Java 8 and beyond. And we'll get to that later, but I wanted to give the grad students a chance to start implementing the plumbing for the later implementations that will use streams and parallel streams, which will be the next major capabilities we'll be discussing in class and doing in subsequent assignments for assignment number 2. So that's basically a walkthrough of the various parts of the program you'll have to address. So again, everybody has to update student.kt to indicate what kind of student you are or how you're taking the class. Everybody has to update the unsynchronized array.java skeleton, and then the grad students have to implement array splitterator. If undergrads are bored and get done quickly and you want to do the splitterator, go for it. I'm not going to tell you not to, but you don't have to. It's just an optional thing for the undergrads. So that's the walkthrough of the skeletons. Please don't hesitate to come to office hours or post questions on Piazza if you have any questions whatsoever. So now that we've walked through the specification and the skeletons, let me just recap quickly how to go ahead and run the unit tests, assuming that you've filled out all the various to-do tags in your unsynchronized array.java, and for the grad students, the array splitterator class, and you've set student.kt to the appropriate graduate or undergraduate value. What you'll do here is you'll go ahead and run all the tests that are in the source test Java directory. And as we had done before, they will go ahead and run quite an extensive battery of tests. Some of the tests are specific for graduate students. Some of the tests are specific for everybody. There's a bunch of tests that exercise things from assignment 1A and assignment 1B, and all the tests are cumulative. So what we're doing here is making sure that any changes or improvements or fixes that you made to earlier versions will continue to propagate correctly into the later versions of your software, which is just a very, very good habit to get into whenever you write production code. You want to avoid introducing so-called regressions into your solution. So you can see there's a lot of tests here. Some of the tests are ignored. You're welcome to enable them if you want to, but I don't think you need to. The tests that we're running here are the ones that we're going to use when we grade your program. And later, when you have the grader installed, you'll actually be able to see what your final score is going to be when you do the proper implementation of all the various methods and fields that you're responsible for filling in the skeletons. So that's just a quick overview of the test. If you end up getting a bunch of reds and you can't figure out what's going on, of course, please don't hesitate to come to office hours and/or post questions on Piazza. So now that we looked through the specification, the skeletons, and showed how to run the unit tests, let me show you how to run the so-called instrumentation tests. To do that, you'll go up into the app folder, source, Android test, and then Java. And here you can go ahead and run all tests. And what this is going to do is it's going to go ahead and launch the Android emulator that you should have set up earlier. And then it's going to go ahead and do some torture testing of the various capabilities. So it'll run your test kind of automatically. It'll do things, as you can see here, like rotate the screen to make sure things are working. Now, at this point, we only have the sequential loops strategy for downloading and transforming and storing the images configured. As we get further into the course, we're going to have a whole bunch of other kinds of strategies. We're going to have one that'll do sequential streams, one that's going to do parallel streams. The sequential streams implementation will look very much like the one we're seeing here because it'll do things sequentially. The parallel streams implementation, in contrast, will do much more scalable performance and processing because it'll take advantage of the multiple cores if you're running on a multi-core processor. We'll also do an implementation that uses completable futures, and then we'll round out the semester by doing an implementation that uses reactive streams and RX Java. And all those other implementations, save the Java sequential streams version, should run substantially faster. Even for this implementation, though, it's kind of fun to see what's going on here. You can see that we're downloading an image, and then we're applying a bunch of transforms to each of the images. And it looks to me like we're applying three transforms per image. We have the original image, we apply a grayscale filter transform to it, and then a couple of other filters that change the colors in different ways. And if you take a look, each image that gets downloaded, there's actually 4 total images displayed because we have 3 filters that are applied. And this is just kind of, plodding along, doing all that processing. If you slow things down a bit, and you can do that by clicking on the little ladybug icon kind of on the top part of the screen here, then you can actually slow down the way in which the test runs, and you can see what's happening. So there's little cool icons that show that we're downloading. There's little clever icons that show that we're filtering. There's little clever icons that show that we're storing and writing to disk and so on and so forth. So if we had more time, which we unfortunately won't, it would be really fun to look through the user interface code to implement all of the test programs. It's all written in Kotlin and uses some extremely advanced Android capabilities like recycler views and other features in order to make everything very responsive, very efficient, very scalable, and so on. So this test will just kind of run for a while. A couple other things to note because it's worth setting things up for the future. You can see that it keeps track up here on the application title bar of the time that's taking to run the tests in seconds. And that's, again, where you'll see a real difference when you run the version that uses parallel processing, or the versions that use parallel processing. They will compute all these computations way, way, way faster than the sequential versions that we're doing here. It also keeps track of the number of images that have been processed. It keeps track of the number of threads that are used. In this case, there's just one, but when we start using the more advanced parallelism mechanisms, you'll see that there'll be many more that are involved. And then it also says what method or what strategy we're doing, which in this case is sequential loops. Now, your particular program may run faster or slower than this, depending on whether you're using an emulator on a fast computer, or hopefully in some cases, people may actually have an Android phone that they can use. If you run this on an Android phone, it should be substantially faster than using the emulator, unless, of course, you have a really, really slow Android phone. So it all kind of depends on the underlying hardware platform, how fast or slow things run. But I really like this particular example as the test driver because it literally shows you whether or not your code is working. And if you have a bug in your code, then the images won't download, or they won't all download, or only some of them will work, and so on and so forth. So you can see here that this will just keep going on and on and on. And I'll probably stop it here in a second because it's not necessary to watch it do it over and over again. But basically, this is just kind of torture testing your code to make sure everything is working properly. So I think with that, we will go ahead and shut it down. But if we let this continue to run, it would end up finishing. Let's see if we can get it to stop by clicking the stop button, and you can see that it basically shuts down and says we stopped running the test. So that's basically the overview of assignment 1B. Hopefully you now have enough information to write the code, meet the specification, and then run the various types of tests, both the unit tests as well as the instrumentation test.